Today, we start with a new concept, what you call a recursion. In the previous sessions, we have seen the concept of functions. As you know, a function is nothing but a subprogram that can be used to handle a specific task or a particular task. Functions can be divided into two categories. Number one is user-defined functions, system-defined functions. If a function that is defined by the user is said to be user-defined function, whereas a predefined or a standard library function is a built-in function. Recursion is nothing but a function that itself is called. A function that is called itself repeatedly. A function that itself is called is known as a recursion. See, I told you in the previous sessions, there is a function call. Whenever there is a function call occurs, automatically control transfer to that location, executes all the statement there, then control return back. Let us go through one example program, writing finding of a factorial of a given number. Factorial of a given number using normal program, then functions, and then recursion. Let us see. Here it is a normal program. There is integer main. If you are using normal compiler, it may be void main. You have to declare the variables. We require a number n. I is equal to 1, f is equal to 1 because we know even 0 factorial value is equal to 1. First, you have to read any number. For creating a new line, \n, enter any number. You have to read it in the terms of scanf %d because it's an integer %n. I'm choosing a loop called a while loop. While I is less than or equal to n, I told you earlier, if you write only less than, if you want to find out the 5 factorial, you will get only 4 factorial. F is equal to f into I value need to be incremented, I plus plus. After that, printf \n factorial of a given number or factorial value is %d and it is stored with f, and here we are return 0. This program is over. This is the program for finding factorial of a given number. It's a normal program. Let us see how to execute it. We have to declare the variables. Integer n is a number, I initial value is equal to 1 and f is equal to 1. We are initializing both I and n are 1s. We have to use a statement called output statement, enter any number. You have to read it, scanf %d %n. Okay, right. I'm taking a loop called while I is less than or equal to, while I is less than or equal to n, that should be opened. F is equal to f into I value need to be incremented. This loop will be continued until the condition false. Printf \n factorial value is %d and the factorial value is f. That's it. Execute the program. Whenever you have errors, it displays some error. Enter the factorial, enter any number 4, you will get 24, that is factorial value. If you give 5, the value is 120. Now, I'm going to convert this program into functions. I want to convert this program into functions. I told you earlier, you can have number of ways to write the same program. Here I am defining integer, there is a written value, and factorial, it is a function prototype declaration before the main function. There is a main function, integer, for example, n, printf, \n, enter any number. You have to read it. Scanf, %d, %n. Printf, factorial value is equal to %d. Here I'm calling a function what you call fact of n. Got it? Fact of n. Here I'm calling a function what you call fact of n. Return 1, return 0. Now here the function is integer fact of. Here the parameter is you can take n or m, your wish. Integer I is equal to 1, f is equal to 1. Same, everything is same. While I is less than or equal to m, f is equal to f into I value need to be incremented, I plus plus. Later, here, the return type is integer. That's why I'm returning the value, what you call return f. So what happens here? Factorial is equal to %d. What is %d? Factorial of n. Fact of n is a function call. Then what happens? Immediately, function will be called. N value will be copied onto m. While 1 is less than or equal to 4. Yes, within the loop, I. So f is equal to 1 into 1, 1 plus 1, 2. Same way, later at the last, it returns f, factorial value that will be printed in the terms of %d. Or you may write the same program by using void also. Here I am writing integer. Fact is a function. We require an integer variable. Here what I am doing after that, I am writing printf \n. Factorial value is %d. Fact of n, I am calling a function called a fact of n. Fact of, then over. Here I am writing a factorial. What is the return type? Integer. Function name? Fact. What is the parameter? M. Here we require the variables. Here we don't require any kind of variables like this. I, f is equal to 1 within the main program. Within the function, what you require? I is equal to 1 and f is equal to 1. Then I am taking here, I've written m. That's why I'm going to modify this is m. Everything is same. Then what happens? Here, the return value, here it is, the return value is integer. That's why I'm returning f. This f value will be copied. Whenever there is a function called fact of n, immediately control transfer to this location. Then execute the program. Enter any number 5. The factorial value is 120. You may write the same program in number of ways. Here, you write void here. You can directly print the factorial value here itself, or you can return the value. See, this is the program for finding factorial of a given number. What is that? Factorial of a given number. Now move on to recursion. What I told you, recursion is a method of calling the same function again and again. See, in this case, I'm going to take up integer. There is a function fact, integer n. This is a function definition. What I'm doing here is if n is equal to 1, return 1. If n is equal to 1, return 1. Otherwise, return n into, I am calling the same function with n minus 1 parameter. Be careful, very, very important. Listen. What happens? What is n, for example, n is equal to 5. Is it 5 is equal to 1? No. Else, what happens? Returns 5 into what? Fact of n minus 1. What is fact of n minus 1? Fact of 4. Again, this function will be called 5 into, yes. Here, what is fact of 4? Is it 4 is equal to 1? No. Return 4 into fact of 3. Again, what is fact of 3? 3 into fact of 2. What is fact of 2? 2 into fact of 1. What is fact of 1? 1. So 5 into 4, 4 into 3, 3 into 2, 2 into 1. This is equal to 120. That means a program that itself is called repeatedly, that is called as a circular. This is also called as circular definition. This is also called circular definition. Listen. You may take, I told you, you may take either n or m, formal arguments, actual arguments. Okay. Then here, if n is equal to 1, I can say that return 1. Otherwise, return n into fact of n minus 1. That's it. Everything is same. Everything is same. Instead of computational activity, what I did, the same function can be called again and again. The same function is called again and again. This is called as a recursion. What is that? Recursion, also called as circular definition. This concept is everywhere in C++ or Java or Python, any other language. We have a very important concept, what you call recursion. Once again, this is a factorial function. What I'm checking, if the given number is equal to 1, what I'm doing, return 1. If the given number is 5, so is it 5 is equal to 1? No. What it means, 5 into fact of 5 minus 1. What is 5? 5 into fact of 4. 5 into 4 into fact of 3. 5 into 4 into 3 into fact of 2. 2 into fact of 1. 5 into 4 into 3 into 2 into 1. So you will get 120. This is called recursion. In the same way, you can do 1 plus 2 plus 3 plus up to n, sum of n natural numbers. What we can do, it is a function. For example, integer, there is a function called sum and the parameter is n. if n is equal to 1, for example, return 1, else return n plus sum of n minus 1. Return n plus, what is n? Given number. What is n? Given number. Here, see this. For clarity, I'm writing again. Return n plus sum of n minus 1. For example, if we give n is equal to 10. 10 is equal to 1? No. Else what happens? Return n. What is n? 10 plus sum of 9. Again, sum of 9 function will be called 10 plus 9 plus sum of 8. Again, 10 plus 9 plus 8 plus sum of 7. 10 plus 9 plus 8 plus 7 plus sum of 6. 10 plus 9 plus 8 plus 7 plus 6 plus sum of 5. That means I told you earlier, the same function is called again and again is said to be a recursion. This is also called as circular definition. Recursion is a process of defining something in the terms of itself. In the terms of itself, it is a process of invoking, calling a function by itself. What you call recursion. Got it? Very, very important topic. What you call recursion is very, very important topic. Say this. In the same way, you can do GCD of numbers, anything. You can try it out on another examples also. You can try it on another examples too. Once again, I'm telling you, in the case of functions, functions can be divided into how many types I told you earlier? There are 4 types of functions. What is that? Number 1 is a function with no arguments, no return type. Arguments and return type. Arguments and no return type. With no arguments, with return type and everything. 4 categories of functions we have. And you can execute all the programs. Whatever the programs you have to execute all the programs in the case of functions so that you can have a clarity. Even I will send you some other example programs also so that you can execute to write a C program to check where the given number is perfect number or not using functions, prime number, between range, quadratic equations, sorting, searching of elements, matrix multiplication. You can pass array to the function. You can pass variable to the function. Even there are 2 other options also available, call by value, call by reference. For example, if you are going to send the value, that is called as call by value. If you are going to send the address, that is called as call by reference. I will tell you the topic in the next session because it is a concept related to the pointers. If you have a basic information related to the pointers, then only you could understand what a call by value, call by reference means. Okay, this is the information related to recursion. Okay.